Today I'd like to walk you through a demonstration of Cobalt Strike. This demonstration will utilize our demo range we provide to customers to try out the product. I'll be using version 4.5, and as we go through this demo, I will be using various attack techniques, but those are not important. If you'd like more information about Cobalt Strike and utilizing it in a real engagement, you can take a look at our training that we provide on our website, and we also have several training partners who provide very in-depth red team training using Cobalt Strike. So let's get started in this demo. The first thing to understand with Cobalt Strike is it is a client-server model. Everything that we do, we will interface through the client. The client connects to the server. The server serves for us to connect and interact with Cobalt Strike. It also allows the beacons or the agent that's deployed to a target to interact with us as well. So we as the operator will influence these agents, these beacons, through this interface. The team server, the server environment, the command and control environment has already been set up. Setting up, configuring, and building a command and control infrastructure is beyond this demo, but there are plenty of training courses, blog posts, and resources available to understand how to build and deploy a command and control environment. So we'll just get started by logging in and starting Cobalt Strike up. This is the default GUI that you see when you start Cobalt Strike. We have several menu items. This section here shows all of the agents or the beacons that we have control over. We've got an event log that shows things that occur as people log on, log off. We get new beacons, various items that give us some information about things going on. When it comes to views, we have two main views. You can look at it in this table view. You can also look at it in a graph view. The graph view, because we only have one target running right now, is fairly small. As we go through this demo, this will grow, and we can show you how that changes as time goes on. Cobalt Strike, being a client-server model, needs a server set up so that this beacon here can communicate to the team server. That is done through listeners. So if I look at my listeners, we have several listeners already started. These are HTTP, HTTPS, and SMB. All of these listeners provide a means for a beacon to communicate. Each one of these will be associated to a payload so that when we create a payload to be deployed on a target, it will connect to whatever listener you chose. So very important component of Cobalt Strike and part of the C2 development plan. Cobalt Strike is a framework, and because it's a framework, there's a tremendous amount of flexibility in configuration. One of those is the malleable C2 profile. This profile here defines all of the configuration options that you can customize for Cobalt Strike. I recommend reading through the documentation on malleable C2 profiles and looking at a lot of the examples posted on the web, because this can be quite complicated and because there's a lot of flexibility and options. Not only can you configure a profile, you can actually load external scripts to enhance your capabilities, the visualizations, just more or less tune how Cobalt Strike works and customize it for yourself. I'm going to load a couple scripts. I've actually loaded a couple already. But these things, they're called aggressor scripts. That's the language that these are written in. If I load this, I simply just browse out to a location where I've already created my script. And so in this case, I'll just reload process color. And it's already loaded, but that's fine. So I have my scripts already loaded. So these are going to enhance the visualizations that I have in Cobalt Strike. I'll show that in a moment when we get into interacting with the beacon. But I can extend this. These are just two small scripts. If you'd like to really dive into this, I recommend looking at our community kit that we maintain. And this is a curated list of add-ons, tools, scripts that the Cobalt Strike community has built and created. There's a tremendous wealth of information in here to utilize a lot of the advanced features within Cobalt Strike. So it's a great resource to have. Before we can continue, Although I do have an agent and I have a beacon running here, I had to do something to get this going. So let me show you how this occurs. So we have our listener set up, we've loaded our scripts, everything is ready to go. We need to create a payload. Creating payload is under the attack packages, and there's several types of payloads we can create. I'm going to focus on the executable type. We're going to create an exe file to launch on our victim. There are two types that we can consider. This one here is the staged one, which means it's a small piece of stub code that connects to the team server and downloads the entire beacon. Or we can have one fully staged, and this one is fully self-contained, ready to go. It doesn't need to pull anything additional down from the team server. On a side note, from an operational security stance, we recommend disable staging. It opens up your environment to more than you may want, and in most cases, fully staged beacons are more than enough. So I choose this, and again, payloads are tied to a listener, so I must choose a listener. So we're going to use the HTTPS listener, and everything else checks out. You can see there are several other types of payloads that you can choose. We're going to use an exe, and I generate it, and I save my exe where I'd like to save it. Now, how did I get this to this remote target is beyond the scope of this environment. I'm using something called the assume breach model. In other words, I'm really not trying to test how I exploited this target to gain access. There are several methods that this could have occurred. This could have been through phishing. I might have been using a penetration tool like Core Impact to take advantage of some weakness and deploy a beacon. There are several ways to do this, but oftentimes in these red teaming and threat-based scenarios, you assume certain actions and start at a certain point. And that's what we're going to do here. We're assuming that I gained access to this target by some means and move forward. And in the next section, we will break this down even further and start to look at how to utilize and interact with Beacon. At this point in time, we're ready to interact with our beacon. Again, we're using an assume breach model where we're just starting our scenario, assuming we gained access to this target. Interacting with the beacon is there's a few different ways. We have several GUI options, so when you right click on a beacon, you will see several menu items to do various things. One of those is interact. Let's choose this. This brings up the standard payload window within Beacon to where you can run commands. So you can see here, we can start to run various Beacon commands. If we'd like to know what commands are available, we can read the documentation. You can also type help, and you will see you get a large list of post-exploitation options. Don't let this list overwhelm you. Time will allow you to figure out what you do and do not need based on the scenario and the situation you're dealing with. So I ran this help file. One thing to note, if you remember, we ran these scripts. This is the standard help, and you can see it shows a command and a description of that. There's another help file that was created by the community called help color, and this is, let's run this here. One thing, the other helper is you can type tab and it'll tab through the various commands. So I'm going to type help X. Help X is a command that was added by this help color script. So this is non-default, but what it allows me to do is this was created as a situational awareness script to help the operators of the program understand what these things are doing and what they may or may not expose by running that command. In other words, green is showing it's using API, and green, yellow, and red, various different things. So in this case, the authors of this script decided that red had more of a risk of exposure and being caught based under certain conditions. So this allows you as an operator to say what is good or what is bad that I want to run. Cobalt Strike is a framework, and it allows you to go as shallow or as deep as you would like. The creators of this script understood that and wanted to have something to help them. That's one of the real nice reasons for using and customizing with scripts. And this is the primary way that you're going to interact with Beacon, through the this interface here, through the command interface, or through various right-clicking and choosing various explorations. For example, if I wanted to browse the file system, I can open up File Browser, and this is going to run. I will say, I'm not seeing anything now, and this is a really, really important concept to understand about Beacon. And once we dig in and start to work on our situational awareness scripts, I'll touch on why we're not seeing any input yet, although we ran this to show us the files. We'll touch on that in a moment. Now that we have a little bit of understanding of how to interact with the beacon and issue commands, let's begin to run some of these commands specifically to do situational awareness with some built-in post-exploitation commands. Situational awareness is really just the practice of understanding what you have in relationship to this beacon. So yes, we have an agent, we have a beacon running on a target, but we don't know a lot about it. We need to dig in and learn a little bit more. So let's start by looking at the processes. We're going to run PS on this thing, and we're going to list this. And you notice it's taking some time here. This is taking some time. Why is it taking so much time? Well, if you see this counter up here in the top right, this is the last time the beacon came in. So if you notice, once this crosses over a mark, now we got some information over here. This is really important because beacon is on a sleep timer. Beacon is asynchronous. In other words, beacon calls home to get jobs from the team server. When I issue a command, like when I typed PS here, I queued a command on team server. This is not an immediate response to the beacon. This is a really, really important concept if you've never worked with reverse asynchronous agents before. If you'd like to change that so that you can gain quicker access, you change the sleep time. So let's change this to sleep 520. And what this is going to do is it's going to tell the beacon to go to sleep for 5 seconds with a 20% jitter. In other words, a plus or minus of 20% based on whatever that time is. So it'll create a range. This allows you to have callbacks not to be exactly on the same time. There are different ways of doing this and some pros and cons. On a normal engagement, I like to keep this in the 3 to 5 minute range. And yes, I said 3 to 5 minutes. I really like to go slow and be very, very precise. But if you'd like to go quicker and speed things up, again, it's a framework designed for you to do and use how you'd like. That's what you'd want to see. So if you remember before, when we ran this file command, nothing seemed to work. It took a long time. That's because the callbacks were going so slow. Now that I have it at 5 seconds, if I choose to browse the file system, such I want to see what's on the C drive, here, the next time it calls back, it's making a response. So this GUI here is really just sending out commands. You'll see the host called home. It's just issuing commands in the background. So as I browse through the file system, every time the agent calls in, I'll get an update. And that is important to understand. All commands work this way. So if you have long sleep times, just be patient and wait. These are not designed to be interactive. Although if you do a sleep 0, this will go as fast as possible and will call back constantly. It's still doing a reverse connection, calling home, but it's doing it as fast as it possibly can, which if you notice in the timer up here, you'll start to see it just pop back really, really quick. I'm going to slow that down because I don't need that much traffic flowing. We'll go back to a 5-second timer. That's plenty fast for me for right now. So let's get into situational awareness. We've gained access to this target. We need to understand our context. So we can run something like pwd. What directory are we running in? We can also run help. Let me run help net. There are several net commands, and if you're familiar with the net.exe command in Windows, these are an API equivalent to many of those commands. So instead of running cmd.exe that calls net.exe, these actually call the underlying APIs similar to how those real tools work. So I can start to ask questions such as, what domain am I running under? Or what user am I running? And I'm just going to queue up a bunch of these commands. Who's in the local administrators group? What computers do I know about? And maybe what are the domain controllers out there? So I start to ask a bunch of questions, and I've queued these things up, and I kind of just popped them out very quick. And now let's assume that this was my basic situational awareness process. Normally, someone would have some sort of like a script to follow, a set of commands to run, certain tasks. So let's assume this is what I want to do every time I jump on a system, I gain access. I want to understand what the context is. So in this case, what I can learn was I found out that information about my user, what users are here. I saw that this is the domain I'm on. So now I know what domain I'm at. I know I'm running right here as this Ruth Lane user. Got the IP address of the victim system. So I got some basic information, and even to the point where now I know what Windows domain it is. I have the domain name and the IP address. So I have some basic information to start to understand. There's a concept that often happens, whether it's part of a official process or something that you do. You gain access to a target, you perform situation awareness. Based on that information, you decide what to do next. And that's really all we're doing. So we're interacting with the system, issuing commands, learning some things about it so that we can make decisions later on. So maybe we've gained some information here. I'll also show that you can do some port scanning. Port scanning is not something that's always done in every red team engagement, but sometimes you'd like to do something maybe a little bit more strategical or surgical so that you can look for specific types of items. So if I look at our target list right now, we've got a couple things. So as you've noticed, as we've discovered these targets, they get populated here. So we start to get a target list. We can extend this target list through port scanning and other types of enumeration. So this can be done in a couple ways. I can interact and port scan from a GUI side here. Depending on what you've done, you may or may not have an IP address in this range right here. It just really depends on what you've discovered on what's populated here. If this is not what you'd like, and this my preference, again, this is a framework and allows you to have preferences of what how you'd like to run it. I prefer to do a command line console. So I have the command I'm going to run kind of right here for a nice copy and paste. Again, pro tip, I enjoy having a text document of copy and pastable commands so that I can quickly reuse them or quickly modify them if I'd like. So in this case, I'm going to run this command. So we're making the assumption I've done some situation awareness, and I have a reason that I want to run this particular port scan against this subnet and these ports. These are just common ports of services that might be interesting. To note, with this port scan command, if you've used Nmap very much, you see this option none. This means don't ping using ICMP or don't use ARP to tell if the host is alive. Assume the host is alive is what none equates to, and this is the number of threads to run. So similar to the options you might have in Nmap, but not nearly as robust as what you do with Nmap. This is very much a targeted approach. So let's start our port scan. This is going to run, and just like anything, it just takes time. It's going to run in the background. And if we can catch this in time, we should be able to see the jobs that it's running. Yep, so there's show that it's still running. You can type the jobs command and actually see what's going on here. This will just take a minute, and we'll eventually slowly identify targets and start to populate the list. And we can start to see some data coming in now. Okay, here we go. So now we're getting some output. I'm not really worried about the output right now. This is more or less what's coming in real time. But what I do want to show you is, you see how this tab turned blue? Whenever something new appears in a new tab, it's going to be blue. I like to look at these as something I need to address and say, oh, there's something new, let me look. And the reason we're getting new is, as the port scanner is going, it's populating the targets field. So you're starting to see more targets out here, and it's starting to figure out things about these targets. And this is a nice way to start to see what's out there. The targets view has a couple extra things you can do, such as I highlighted everything, right click, and I want to look at the services. This will show me all of the services that it knows about. Now, this is very, very targeted based on our port scan, but all the services associated with those systems. So we can see, based on these IP addresses, these ports are opened, and if it could get a banner, it pulled a banner. Again, these are very, very rudimentary and targeted port scans, but this gives us some information. So back to that concept of gaining access to a target, performing situational awareness. Now I'm gaining information to make decisions to move forward. This gave us quite a bit of information. We understand the user, we know the domain, we know where the domain controller is, so we've got a little bit more information. In the next section, we're going to conduct situational awareness using alternate and third-party tools through the ability to import add-ons. We'll talk about that in a moment. We left off in the last video performing situational awareness using built-in post-exploitation tools. And while these tools are really, really great, they may not have everything you need. And I've mentioned this before, but Cobalt Strike is a framework, and part of that framework is the ability to load third-party tools. This can be done through PowerShell, or in the case we're going to demonstrate, through a .NET. We can use the command execute assembly to execute a .NET process. So anything that is compiled with .NET, and as long as those versions match with the .NET CLR on the remote system, we can run this in a temporary process in memory. This allows us to really, really extend our capabilities. And in order to show that, we're going to use something from this GhostPack toolset. Specifically, we want to run Seatbelt, which is a safety check or situational awareness script. It allows you to go really, really in depth and understand what's going on. We'll also be using a tool called SharpUp, which if you've ever used the PowerShell script, this is a version of that written as a .NET assembly. So let's see how we can do this. Again, I'm going to use my notepad to help me copy and paste things properly. But the way this is run is we're going to run execute assembly, the target binary that we are going to use. So in this case, we went on a seatbelt, and any parameters that go along. So this is not going to be a demonstration of how seatbelt functions. There's quite a bit of command line options that you can use, but we're going to use this to run one of those. So I'm on my beacon. Let's get this going. And one thing that you're going to note as we run this is seatbelt pushes back a tremendous amount of information. And while this is running, I will go ahead and kick off SharpUp as well. So as that's running in the background, we'll let this go. So we'll get this one started as well. We can take a look at our jobs and see that they are, I can see I've got, oh, and I lost it. It popped down, but there are two jobs running. So as it's pushing this back, you can see the method I'm using on these commands is to bring this back over this output. And it's getting a lot of information. It's hard for me to see what's happening. It looks like SharpUp did complete. Seatbelt is still running, and there's a lot of information coming back. I do want to let seatbelt finish, and then we're going to look at an alternate way to look at this information besides through this GUI. As you see this is coming in, it's just a lot of information. It may not be how you want to look at this and dig into this. And for this demo, I'm not actually going to analyze this, but if you're really, really doing this, you would spend time analyzing and dissecting what output is in here so you can make more effective decision on how to do something. You might find other types of privileged escalation, other tools, other processes, things to target that might help in your engagement that you're working through. So it completed it, and I can see it's finally finished. But again, it's a lot of information, and it may not be the most friendly way to look at this. So there's another way to gain access. All of this information, everything is logged on the server. So I can SSH over to our team server. So I'm going to SSH to the team server, and in this case, we've set up team server in /opt Cobalt Strike. And this is the normal Cobalt Strike files that you're going to see in here. And we're specifically we're interested in the logs directory. So so the way Cobalt Strike logs is by date of activity. So let's go into today's date. 20. And I'm going to see a lot of information here. So there's various logs. We can see there's going to be a copy of the event logs, any of the web logs, any of the web traffic that's been coming back to our team server. We have a log of that. And we have this IP address log. And this IP address log is what matches up to our target's IP address up here. So you know that this is the IP address of that system. So let's go into there and see what we have in here. And as it stands now, we've done just a few commands. There's other things that can be logged in here, depending on activities, such as screenshots, keystrokes, etc. But in this case, we've just done our beacon log. And this beacon log, let's just tail the beacon log, like the last 100 lines. And we'll see this is all of the output that we were just seeing in this window. We could copy this file down, open it in a more robust editor, and start to dig through and analyze this. This is a good way to extract something that we can process later on. And this is a really, really effective way of utilizing third-party tools, in this case, .NET assemblies, to extend your capability. Up to this point, we've done some simple situational awareness. We understand a little bit about the context of this single connection that we have into this network. Let's use this and pivot to internal resources via a SOCKS proxy through this beacon. So we actually have the ability to proxy, to tunnel, if you will, traffic and tools through a beacon to the internal target. We're going to utilize this so that we can browse internal websites for more reconnaissance. At this point in time, we are just doing this through this single box. To get this started, there's a couple things we're going to want to do. The first thing is our target system, which we're running our client on Windows, we need to set up our proxy settings. So let's look at proxy settings here. So we're going to do this through HTTP proxy and use our browser as the tool to pivot through. We want to turn off automatic settings. We want to set up a manual proxy, turn this on, and we're going to proxy this through our team server. So when we set this up and we establish a proxy, the listening port that we set our proxy is actually on the team server. This is important to understand. If you've locked down your team server and you want to make sure that you have access, you'd want to make sure that this port is open and available from whatever target you want to proxy through. So let's do, whoops, let me put this in the right spot. There we go. Okay, so I'm going to proxy through the team server over port 8080. So I have that set up, and in order to kick this off, under my beacon console, I simply run the SOCKS command and what port I'd like to turn on. I also want to go change my sleep to, you can go interactive or maybe a sleep of 1, but remember, whatever this is, because it's asynchronous, it's actually tunneling your traffic through this reverse connection, so you can get timeouts if you don't go quick enough. I can look at my proxy pivots here, and you can see that I've got this new one set up. So on this beacon that's running as PID 3080, you can see 3080 here, we have this SOCKS4 proxy on port 8080. So in theory, we should be able to open up our browser and browse to internal resources. So I've got a couple that I want to try. Again, I would have learned these through some of my enumeration, through port scanning, through other means that I would have learned about this. And the way you gather this was not as important as the capability that you can do. So what I just did was I browsed this website. This is not something public or available through my local machine. My traffic is tunneling through this beacon to the internal location. This is a great way to pivot additional tools, in this case, a web server, into internal resources. So in this case, I found an Apache server. This might be something I want to look at for further consideration of attack. It might be an interesting target. So this is all still really, really great situational awareness and can be very, very useful. In this case, I'm finding the OWASP juice shop, and you can see it's loading a little slow, and that's understandable because traffic is being tunneled through a reverse beacon connection. So one thing to be aware of whenever you do any type of these connections is do not expect things to run really, really quick. Part of the cost of this type of access is tunneling and less speed. That's very, very common. So I see another target. This could be very much a target that I want to browse to enumerate possible consideration for a future attack. And we'll look at one more here. But this is a really, really interesting way of using the SOX proxy using a browser. This can also be used using tools on a Linux box like proxy chains to proxy tools like Nmap or Mpacket to provide additional capability to reach into your target. Again, a little bit slow, but that's not the point. The point is I can actually connect to the system and reach internal resources from outside of my Cobalt Strike interface. Okay, up until this point, we've worked off a single target, the initial target that we had. So we only have one beacon. If this was a real engagement, we would have performed a lot of this situational awareness, analyze this, and start to make decisions. So this is where we're starting right now. And our goal is to start to move from this target through lateral movement and privilege escalation. We're going to use the Kerberoasting technique, which I'm not going to go into the techniques, but I will leave references behind so you can dig into this. You can find more details on MITRE ATT&CK's webpage on Kerberoasting. We'll also be using the Ghost Pack tool called Rubius to help with this. This is a .NET assembly, so if you remember, we're going to use the execute assembly features in Cobalt Strike to run a Kerberoast attack to look for potential credential material that we can crack. So let's run this. So I'm going to run this by using this command here, execute assembly, to our Ghost Pack tools. We're going to run the Kerberoast option and send all of the output to this hashes file. One thing to note, the output of this is in a hashcat format. Hashcat is a password cracking tool, and this is what we can use once we get these hashes to crack anything or potentially crack something. So let's just paste this in. We're going to run this here. Okay, so it's running. It found one Kerberoastable user. It found this MSSQL_SVC service, and it gave us some information. So what's important about this is it saved this to the local file system. If you looked at our path, it was relative to where our path was. So if I list the files in this location, I should see hashes.txt right here. So this is stored remotely. In order to pull this back, I need to download this. So I use the download command. The paths are relative to your location. So I download hashes.txt. And let's view the downloads. So now we see this hashes file. One thing that's important about Cobalt Strike is when you download this, everything is relative to the server. And we need to synchronize these files to our local client. So we'll synchronize this. I'll just put them in my local downloads for now. And now I synchronize that, I pull this, and I have my hashes file. This hashes file, not so important for this demonstration, but this is the hashcat format that can be used for potential cracking. So what we're going to get from this is we're going to pass this over to the hashcat tool, crack a password and then have the ability to run things as this user here. Now that we have successfully Kerberoasted an account and extracted hashes, we use the tool Hashcat to crack this password. The actual running of the tool is beyond the scope of this, but it involves running Hashcat with a set of parameters against the hashes file. The result gave us a password for this account. And based on the prior enumeration that we've done, we realized that this account has privileges. We are going to use this account and password to laterally move to the domain controller, and by laterally moving, we will also have performed privilege escalation. So let's do that now. So we're going to start by taking that information and using the command make token. And what this command is going to allow us to do is change the security context of our currently running process. Currently, we're running a beacon under PID 3080. It's actually going to change the context of our current environment so that these credentials will be passed as we perform various activities. So in order to do this, we run make token, and it's the domain / user. And then the password. We will run this, and it's going to come back. There is some confusion because it says we're impersonating Ruth Lane. That's because that's the current user that we're running under, but this has been injected, and now we can attempt to utilize this. So a quick way to test this is to see, does this account have privileges now to the domain controller? And yes, it does. We have successfully connected to the domain controller. This is a very important step because now we can utilize this. We've successfully laterally moved by getting information, utilizing that information. We can actually now perform full lateral movement. So it's not just browsing the files, but we can actually test out the SMB capabilities of Cobalt Strike. So we're going to use the jump command. And this is the lateral movement command in Cobalt Strike. We're going to use the PSExec 64-bit version. This is the Cobalt Strike beacons implementation of the PSExec technique. We're going to go to the domain controller. And let me type that one properly. It is case sensitive. So now it's going to attempt to connect using the PSExec service, PSExec lateral movement technique, to establish a privilege level user running an SMB beacon. And SMB beacons are slightly different than HTTP because they only allow communications internal over the SMB protocol. It can take a minute to stage. It's staged. So now we have a new beacon. We got an event log showing that we got a new beacon running as system. That's the nature of the PSExec command. That's how this is runs. We got a new symbol here, this link. This link says it is a linked beacon. That tells us it is linked to another beacon. Beacons are always chained up. So in this case, if we want to see how this linking works, now we can open up the GUI and see the relationship. So when I start to issue commands here on this system, it actually tunnels through this system back to us on the team server. And this is important because the concept of sleep that we talked about earlier is actually driven by the parent beacons. And let me show you that real fast before we get too far into this. Let's interact with this. And if I do I'll just do an ls on this here, that command is issued and runs back through this remote box. So if I do a sleep, let's say 10, it shows sleep 10, but it actually shows that it was changed here. And if we flip over to this box, the sleep command was actually issued to the parent. And this is important because SMB beacons do not have the concept of sleep. But at this point in time, we have successfully laterally moved, gained access to the domain controller, and can continue dumping credentials, moving through the network, doing other things. This was a huge enabler for us to possibly achieve some other goal that was not only compromising a domain. But the main concept in this is the understanding of SMB beacons. SMB beacons are really, really useful. One of the techniques that works well is to run a normal user account that says has access to an HTTP proxy to get outbound to the internet as a normal user, but SMB to yourself as a privileged user so that all traffic leaving the network flows a standard path. And all you do is have inner SMB communications to talk to each other. But the concept of SMB lateral movement is a very, very powerful and capable feature of Cobalt Strike.